Just a quick note before we get started. This video is part of our Mathematics and Statistics module in our FE review course. If you would like access to the complete module right now, as well as other FE review modules, a practice exam, and live Q&As, make sure to go to the link in the description and go to our FE Exam Academy. Once you go to the link and join, you'll have access to our full support in passing your FE exam. If you find this video useful, make sure to leave a like and subscribe to the channel for future updates. That being said, let's go ahead and get into today's topic. Welcome to the last segment of the Analytic Geometry section for Mathematics and Statistics. In this segment, we are going to be covering some problems on ellipses. The formulas for ellipses in the FE reference manual can be found on page 43. As you can see right here, we have the standard form. The standard form applies when the ellipse is at 0, 0. And we also have a formula for the eccentricity and how to find the focus and the directrix for an ellipse. As always, make sure that you try these problems yourself before you look at the solution. But when you're ready, let's go ahead and begin. So starting off with number 24, here we have an ellipse given to us and we need to identify the center, the length of the major axis, and the length of the minor axis. If you look at the ellipse that we were given, it's already in standard form. As you can see, if you compare it to the standard form we were given in the reference manual, the only difference is that this one is not centered at 0, 0. It has some transformations, as you can see here. With that in mind, we can start off with identifying the center of the ellipse. We are going to find the center of the ellipse in the same way that we found the center of a circle. So we're just going to look at the transformations that we're given here, and we're going to take the opposite of what's in the parentheses to give us our x and y coordinates. So in this case, looks like our x coordinate is going to be a positive 2 and our y coordinate is going to be a negative 3. So this is going to be the center of the ellipse. We also need to find the length of the major axis and the length of the minor axis. So let me go back to the reference manual real quick to show you what that is. So looking at the diagram that we were given for an ellipse in the reference manual, you can see that the ellipse has a length across the x-axis and the length across the y-axis. The major axis is always going to be the bigger of those two. So when we have an equation like the one we were given, the way that we find out which one is the major axis and the minor axis is by looking at these denominators that are under the x and y terms. As you can see, it's a squared and b squared. A squared is always going to be the bigger of the two, and it will always correspond to the major axis. So let me show you what that means, okay? So I went ahead and rewrote our equation for us, and if we compare it to the standard form, we're gonna need to find out which one is a squared and which one is b squared. So again, a squared is always the bigger of these two denominators. So in this case, our a squared is going to be equal to 16. So our b squared is going to be equal to 9. And then in order to find our a, we're just going to take the square root. That's going to give us a equals 4. And b is going to equal to 3 after we take that square root. So I went ahead and drew an ellipse here just so I can make an illustration just to make it clear what is going on. So basically from here to here, we know it's going to be 4. And then from here to here, it's also going to be 4. So because this is our major axis, it's the longest of the two axes running across the ellipse. The total length of the major axis is going to be equal to 8. So major is equal to 8. And then if we do the same thing for the minor axis, it's going to be basically like this. And it's going to be 3 and 3. That's going to give us a length for the minor axis equal to 6. So if we take a look at our multiple choice, the answer is going to be B. So just a quick recap, because this is the first problem. What we did was we found the center of the ellipse in the same way that we find the center of a circle, by taking the opposite of these transformations. And then we took our standard form equation in order to find a squared and b squared, remembering that a squared is always the bigger one. From there we found a and b, and that gave us the length of our major axis once we added these up, and the length of the minor axis once we added these up. So that being said, let's move on to the next problem. Okay, so for this next problem, we need to find the center, major axis, and the minor axis of an ellipse once again. However, this one is actually a little different. If you can take a look here, you'll see that it is in standard form, just like the previous one was, but something about this is a little different. So when we find the center, that part is going to be the same. We just do what we did for the previous problem. But once we look at our equation, you'll notice that a squared is 25 and b squared is equal to 9. The difference from the last problem is this. So in the last problem, the a squared was under the x term, and then the b squared was under the y term. So what that told us was the major axis was going to run across the x coordinates, right? And therefore the minor axis was along the y coordinates. For problem 25, it's a little different because now the a squared is under the y terms and then the b squared is under the x terms. So that tells us that now the major axis is going to be along the y coordinate. So basically what that means is that the ellipse is going to look like this. It's going to be taller than it is wide because the major axis is going to be running up and down instead of left to right. So in this case, the center of the ellipse is at 1, -2. And then we can find our b and our a by taking these square roots. So that one's going to be 3. This one is going to be 5. And then we can draw a little diagram again to show what the distances of a and b are. If we add them up, we'll see that our major axis is 10 units long and our minor axis is 6 units long. So therefore, if we look at the multiple choice, we're going to see that the answer is A. So as you can see, when you're solving these ellipse problems, you need to pay attention to which of the terms, either the x or the y, has the major axis. And the way that you know that is which one has a bigger denominator, and whichever does have the bigger denominator has the a squared terms, which are always associated with the major axis. So that being said, let's move on to the next problem. So here we have one more problem where we need to identify the length of major axis and the length of the minor axis, but we also need to put this equation into standard form. We were not given a standard form ellipse equation to begin with. So I just went ahead and rewrote our equation for us right here. If we take a look at the reference manual once again, we'll see that for the standard form of an ellipse, the right side of the equation is always equal to 1. That is always true for the standard form of an ellipse, okay? So therefore, what we need to do to get this into standard form is we need to get this to be equal to 1 on the right side. In order to do that, we're going to divide the entire equation by 64. So then we're going to end up with x squared over 4 plus y squared over 16 is equal to 1. So if you take a look at the standard form equation for an ellipse, you'll see that this one actually is centered at 0, 0 because it doesn't have any transformations associated with the x and the y. So now we need to find the major axis and the minor axis. We can do that in the way we've been doing. So let's see, which of these is the bigger one? So it's 16. That means a squared is going to be 16 and b squared is going to be 4. Then if we take the square roots, b is going to be 2, and then a is going to be equal to 4. So the ellipse is going to look like this. It's going to be taller than it is wide. So now we can plug in what we know. We know it's centered at 0, 0. And we know that a is 4 and b is 2. So if we add up the lengths for the major axis, we're going to get that the major axis is equal to 8. And then the minor axis is going to be equal to 4. So if we take a look at our multiple choice, we'll see that the answer for this one is going to be D. Okay, so moving on to number 27, we now need to find the vertices of an ellipse given this equation. So let me explain what the vertices are. So taking a look at the FE reference manual once again, you'll see the diagram of an ellipse. The vertices of the ellipse are going to be basically where these blue dots are. So it's going to be the most extreme ends of the ellipse. And those most extreme ends are going to be basically at the end of the major axis for the ellipse. So take a look at this diagram and just keep in mind where the dots are is where the vertices are, okay? So going back to our problem, we need to find the vertices of this equation. So what we need to do is we need to find the length of the major axis to see what those most extreme ends of the ellipse are, okay? So taking a look at these denominators, we'll see that a squared is going to be 36 because it's the bigger one, and then b squared is going to be equal to 16. So then if we take the square roots, a is going to be equal to 6 and b is going to be equal to 4. So we also know that the center of the ellipse is going to be at 2, -1. Now if we draw ourselves a little diagram of the ellipse, once we see that the a term is associated with the x, we know that the major axis is going to run along the x direction, therefore it's going to be wider than it is tall. The center of the ellipse is going to be at 2, -1. And the distance from the center of the ellipse to the vertice, or the most extreme end, is going to be 6, otherwise known as a. So in this case, the diagram ends up looking like this. And we can do a subtraction to see what the coordinate is over here. So over here it ends up being -4, -1, and then over here is going to be 8, -1. So that is how you find the vertices of an ellipse. And if you take a look at the multiple choice for this one, the answer is going to be C. So now moving on to number 28, we once again have a problem where we need to find the vertices for extra practice. So let's see, let's look at what we were given. We were given this standard form equation, and we can identify that our a squared for this one is going to be 25, and our b squared is going to be equal to 9. Now, if we take the square roots, b is going to be equal to 3, and a is going to be equal to 5. Then the center of the ellipse is going to be at -1, 3 when we look at these transformations, and we just take the opposite for the coordinates. So once we know all that, we can take a look at a and see that it's associated with the y terms. What does that mean? Well, that means that the major axis is going to run along the y coordinates, so the ellipse is going to be taller than it is wide. So if we fill out the drawing, we'll have the center at -1, 3, and then we'll have the a distance from the center to each vertex is going to be equal to 5. So if we just add and subtract 5 from the y coordinate of the center, we're going to get that one of the vertices is at -1, 8, and the other one is going to be at -1, -2. So if we take a look at the multiple choice, the answer is going to be B. Moving on to number 29, we have one last vertice problem for extra practice. In this one, we don't have our equation in standard form. I'm just going to rewrite the equation here for us. We actually had this one earlier in one of the problems. We're going to divide everything by 64 once again, because remember, for the standard form of an ellipse, the right side always needs to have a 1 in that place. In this case, we're going to end up with a 1 there, and then we're going to end up with x squared over 4 plus y squared over 16. Now, because there are no transformations associated with the x and the y, that tells us that this ellipse is centered at 0, 0. So now let's find out what our a squared and our b squared is. So a squared is always going to be the bigger of these two denominators. In this case, it was 16. And a, after you take the square roots, is going to be 4. And b is going to be equal to 2. Now, we can see that a squared was associated with the y terms here. So that tells us that the major axis is going to run up and down the y coordinates. So our ellipse is going to end up looking like this. It's going to be taller than it is wide. And then the distance a from the center of the ellipse to the vertice is going to be 4. So we can add 4 to the y coordinate of the center, and we'll get one of the vertices at 0, 4, and the other one is going to be at 0, -4. So then if we take a look at the multiple choice answers, we are going to get D for this one. So moving on from finding the vertices, we are now at number 30, and we need to determine the eccentricity of an ellipse when we are given the standard form equation. So let me go to the reference manual real quick and show you the formula for eccentricity. So as we can see here, the formula for the eccentricity is going to be E equals square root of 1 minus b squared over a squared. So going back to our problem, I went ahead and put the formula right here so we can see it while we solve. So if you look at the formula, you see that we need to find b squared and a squared. So we can do that really easily the way we've been doing. So here we see that 25 is the bigger one, so a squared is going to be equal to 25, and then b squared is going to be equal to 9. So now we can just plug in into our eccentricity equation. So in this case, 1 minus b squared was 9, over a squared, which was 25. Once we do that, you put it into the calculator and you're going to get eccentricity is equal to 0.8. So if you take a look at the multiple choice for this one, the answer is going to be A. So moving on to number 31, we have one more eccentricity problem just for extra practice. So once again, I put the formula right here so we can see it while we are solving. So let's go ahead and find our a squared and our b squared. In this case, a squared is going to be equal to 36 and b squared is going to be equal to 16. So now let's go ahead and plug into the eccentricity equation. Our b squared is going to be 16, and then we're going to have 36 for our a squared. Once you plug that into your calculator, you're going to get a result of 0.75. So if you take a look at the multiple choice, the answer is going to be C. So now moving on to number 32, we have a different type of problem. We need to find the foci of the ellipse that we are given. So let me show you what that means real quick on the FE reference manual. So if you take a look right here, the focus or foci in plural is going to be located at plus minus a times e, 0, for a ellipse that looks like this and is centered at 0, 0. So now let's go back to our problem. So if we look at the ellipse we were given, our ellipse is actually centered at 0, 0. There's no transformations associated with the x and y terms. So let's just write down what we saw in the manual. We saw that plus minus AE 0 is going to be where each of the focus are going to be. So that being said, we need to find A and we need to find E. So we can look at our ellipse and we'll see that A squared is going to be equal to 16 and B squared is going to be equal to 9. Take the square roots and then we'll get A is equal to 4 and B is equal to 3. Now we can find the eccentricity in the same way that we did in the past couple problems. You can look at the reference manual if you don't remember the equation, but basically eccentricity equals square root over 1 minus b squared over a squared. So in our case, it's going to be square root of 1 minus 9 over 16, and that is going to give us an eccentricity of 0.66. So now we know our eccentricity and we know A. So let's go ahead and find out what AE is. So AE is going to be 4 times 0.66. That is going to give us square root of 7. So therefore, that means that one of the focus points is going to be at negative square root of 7, 0. And then the other one is going to be at positive square root of 7, 0. So if you take a look at the multiple choice for this one, the answer is going to be B. So moving on to number 33, we have one more question where we need to find the foci of the ellipse. This problem is going to be different than the last one because in the last one, our ellipse was centered at 0, 0. And it looked just like this one, right? The major axis was along the x coordinates. This one is not that case. So we need to make a couple of adjustments and I'll show you how. So first of all, we can find the center of our ellipse and it's going to be at 2, negative 3. So it's not going to be at 0, 0. That's the first change. So we can find our a squared, it's going to be 25, and our b squared is going to be equal to 9. Now, if you pay attention, you'll see that in the last problem, a squared was associated with the x terms. This time, it is not. For the problem that we are on, it's associated with the y terms. So that means that the major axis is going to run up and down the y coordinates. So what both of those changes are going to mean for us is this. So in the last problem, plus minus AE 0 is where the focus points were. For this problem, it's going to be different. It's not centered at 0, 0, and the focus points will not be along the x coordinates. They're going to be along the y coordinates. So once we make those changes, we're going to end up with 2 plus minus AE instead of this. So this 2 accounts for the center of our ellipse, and the plus minus AE accounts for the fact that the focus points are going to be up and down the y coordinates, okay? So now that we know these changes and we've noted that we need to account for them, we can proceed like we did in the last problem. So we can find B, and it's going to be equal to 3, and A is going to be equal to 5, okay? And then once again, we need to find E. So this is the formula for eccentricity right here. So once we fill in our formula based on RB squared and A squared, we're going to get that the eccentricity is 0.8, and then AE is going to be equal to 5 times 0.8, so that is going to be 4. So now that we know AE, let's find our focus points. So originally our ellipse was centered at 2, -3. So one of the focus points is going to be at 2 plus minus AE. So if we first subtract AE, which is 4, from -3, we're going to get one focus point at 2, -7. And then for the other focus point, we're going to instead add AE to -3. That is going to give us the other focus point at 1. So if you take a look at our multiple choice, the answer for this one is going to be A. So that was the last problem on ellipses, and this actually brings us to the end of the analytic geometry section of the mathematics and statistics module. So the next section is going to be single variable calculus, and we are going to be covering limits, derivatives, integrals, and applications of derivatives and integrals. So I hope that this analytic geometry section part was really helpful. When you're ready to move on to single variable calculus, we'll see you there.